All right, let's get started. Good morning, everybody. My name is Austin Whiteley. I'm a salesman out of our Northern Colorado office here in Fort Collins. This week on our coffee break, we're joined by Cambridge Air Solutions. Jacob's here to give us an overview of their direct fired product line with DX and evaporative cooling. With that said, Jacob, take it away, sir.
Awesome. Thanks, Austin. Yeah, so I'm Jacob Wyckoff. I'm on the Cambridge Air Solutions Applications Engineering team. Really appreciate you all jumping on the long coffee break today to learn a little bit more about Cambridge Air Solutions. Got a tight 15 minutes for you all on who we are, what we do, and then finally going to go through two key applications that we at Cambridge Air Solutions really specialize in. So who are we? We are Cambridge Air Solutions, and our mission is to help manufacturing and warehousing leaders create healthy working environments for their hardworking people. So we do that using the variety of products that we offer: our direct fired heating equipment, direct fired makeup air units, evaporative cooling products, and mechanical cooling products. We specialize in heating, cooling, and ventilating your high bay spaces like warehouses, distribution centers, manufacturing facilities, and other niche facilities like car washes, water treatment plants, airplane hangars. When you see a large open space or a large dirty environment that needs any outside fresh air, heating, or cooling, engage Long Building Technologies, your sales engineer, to help pull us in and help us guide you through that application. So not the topic of our discussion today, but just a product that we have available in select target markets currently and coming to your market soon is our Apex Air high velocity air turnover unit, available from 40 to 80 tons. This is an indoor vertical air handling unit or air turnover unit that delivers efficient cooling across large high bay spaces without the need for ductwork. Ideal choice for both retrofit and new construction projects where ease of installation is a priority, but effective, efficient cooling is a necessity. But jumping straight into our first application we're going to talk about today that Cambridge Air Solutions serves is makeup air applications. These would be facilities like heavy manufacturing facilities, service shops, parking garages, really any facility that has a large amount of exhaust required because they have processes occurring in the space that give off typically gases or fumes that would be harmful for humans to breathe on a regular basis. Code and health considerations would require that you exhaust that air and replace it with fresh 100% outside air. And in any kind of application or climate zone where it's going to get below freezing, where it's going to get cold, you're going to have to heat that makeup air or at least temper that makeup air to avoid a whole host of issues like building pressurization issues, freezing the building, if you were to provide either unheated makeup air or not provide makeup air at all. So we at Cambridge Air Solutions, we believe that direct fired makeup air units are the best solution for these applications, really for a few key reasons. So number one, they're extremely efficient. With 100% outside air direct fired units, you have that combustion process occurring directly in the airstream, which allows you to get the maximum possible efficiency out of the fuel that you're providing. That gives you your 100% combustion efficiency or your 92% sensible thermal efficiency. Because we have no heat exchanger, we therefore have no flue losses. You're not losing any of that heat up through the roof of the unit or up through the roof of the building as you're exhausting those flue gases because there is no flue on the unit. They're also extremely advantageous for these applications because they're able to process very large volumes of outside air. The M Series makeup air unit from Cambridge Air Solutions, available all the way up to 75,000 CFM in a single package. And they're able to give you the temperature rise that you need even on the coldest day of the year. That's something that your other technologies like indirect fired equipment and especially electric equipment can tend to struggle with, being able to provide the needed heat on the coldest day of the year. They're also extremely simple, low maintenance, reliable pieces of equipment that's able to last for a very long time. Typical lifespan anywhere from 20 to 30 years on these units. These manufacturing facilities, they really want to focus on manufacturing the goods they went in business to do. They don't want to worry about their unit firing up. They just want to know that on the coldest day of the year, when they need that heat, when they need that ventilation, their unit outside is going to provide that. And when you're taking a look at these makeup air applications, a few things that you want to think through early on is how do you want to control your discharge temperature? So one option would be discharge temperature control, where you modulate the burner to maintain a select discharge temperature. For makeup air applications, this would typically mean providing neutral air to the space and then either specific space temperature is not a huge concern, or you have some auxiliary equipment that's actually controlling the temperature within the space. The second option would be space temperature control, where the burner actually ramps up and down by increasing or decreasing the discharge temperature to control to a specific space temperature set point. This is great because it allows the makeup air unit to directly control the temperature of the space, get you a tight set point without relying on auxiliary heating equipment to actually maintain the set point in the space. The next thing you want to think about is how do you want to control the unit? So most commonly, these units are provided with a standalone remote control station. It's very simple to operate for the people in the space, but there is a lot of complexity that could be added to this and a lot of features that could be added to really match the controls of the unit to whatever the application would call for. We can interlock the unit with exhaust fans. We can add variable speed capabilities to the unit and ramp the unit up and down based on building pressure or based on how many exhaust fans or which speed the exhaust fans are running at. A huge amount of flexibility there with a simple remote control station. The second option would be a BACnet PLC controller. For those spaces that have a building automation system or a building management system, it would have some pre-programmed makeup air unit sequences in there to allow it to interface and be controlled and monitored by the building automation system. Finally, we could remove that BACnet controller and simply provide terminal strip controls to allow for controls or a third-party controller by others. This would allow them to send the burner and blower enable signal, as well as modulate the burner up and down. They would also get some feedback in the form of digital outputs from our unit to be able to monitor the status of the unit. The mounting for these units is also extremely flexible. So rooftop units are going to be very common for your new construction type spaces where they've already made accommodations to structurally support the unit. Pad mounted units are a great option as well for your retrofit applications where you want to mount the unit just outside on a pad. This is great because it's extremely serviceable from ground level. But if the footprint outside is a concern, we also offer vertical units, a little bit more difficult to service, but minimizes the pad you have to pour. It minimizes the footprint it takes up outside. Along with that, we can also offer indoor units hung from the roof in the form of indoor through-wall units or indoor under-roof units where we provide a plenum package to duct into the inlet of the unit. Because these are 100% outside air units, whenever you're mounting these units indoors, you need to make sure that you're able to supply that outside air to the inlet of the unit. And that's a key consideration you want to think of whenever you're looking at mounting these units indoors. Some of the key product features that we have, airflow ranges from 1800 to 75,000 CFM. We also offer bolt-on DX or chilled water coil sections that would be mounted upstream of the unit. The condensing unit or the chilled water supply would have to be provided by others, but this allows them to get cooling in a single package. We also work with A2L refrigerants for our DX coil, so we'll provide the refrigerant detection system and the refrigerant mitigation sequences as well to allow for compliance with the codes. We also offer evaporative cooling. So evaporative cooling is a great option, especially whenever you're applying these in your more mild climates. For these 100% outside air units, they can provide a huge amount of relief for the people or processes that are occurring in the space. We also offer filtration on these units, both in the intake hoods or as a separate V-bank filter section. These are 100% outside air units, so typically minimal filtration is required. But for those applications that call for filtration, we can offer all the way up to MERV 13 as a selectable option. So these are generally minimally ducted units, meaning you're providing a very small amount of ductwork just to get the air into the space, and then you're throwing that air across the facility. And then wherever the exhaust is located is going to pull that air towards the exhaust. As such, typically there's not a whole lot of ductwork required, and we'll provide that minimal ductwork as well as the discharge diffusers and plenums to allow the unit to show up as a single package for quick, easy installation that the project manager on the project doesn't have to worry about to allow for that quick, simple installation. Moving on to our next application would be space heating applications. These would be spaces like warehousing and distribution facilities, light manufacturing facilities, aircraft hangars, indoor sports facilities. What all of these facilities have in common is that they have very little ventilation that's actually required. And actually the need of the space and this unit equipment selection is going to be driven by the amount of heat required. So we're selecting the unit based off heating the space. And then as a result of providing heat to the space, the unit's also able to meet the ASHRAE 62.1 minimum ventilation requirements. So we actually have a different product offering for these applications. So as opposed to this top example, the draw-through style makeup air unit that we talked about previously with our M series heater, we have a different offering for these space heating applications. We call that our S series heater. It's a high temperature heating and ventilation unit, or HTHV. How that differs from a draw-through style makeup air unit is that the blower is actually moved upstream of the burner into the cold air stream, which has huge implications whenever you're talking about heating a space efficiently, because it allows us to increase our discharge temperature all the way up to 160 degrees. Whereas whenever you look at draw-through style equipment, that blower's in the hot air stream, which limits your discharge temperature anywhere from 120 to 140 degrees at the absolute max. And really, if you tried to operate the unit consistently at 140 degrees, you're going to see very short lifespans out of your blower components, like your belts and your bearings and your motors, because they're not made to be subjected consistently to those very high temperatures. The blow-through style unit allows us to have that high discharge temperature, keeping those blower components in the cold air stream, allowing them to last with longevity, while still providing large levels of heat to the space. Now, we could speak for an hour on why this is so important for heating your high bay spaces for these heating-driven applications. We don't have that time today. So I'm going to go through it real quick, the science behind it in about 1 or 2 minutes. But if it doesn't make sense, you want to learn more, definitely reach out to your Long Building Technologies representative, and they'll be able to connect you with our literature or pull us in for a more in-depth conversation. So take, for example, a space that has an 1118 MBH conduction load. The conduction load being the transmission losses through the walls and roof of the space, as opposed to the air load of the space. Things like infiltration and ventilation would make up the air load. Whenever you're heating a space using 100% outside air, you need to make sure that the total load, the total heat load of the space is covered by the equipment that you provide, but also that the conduction load specifically is covered by the equipment that you provide. Because when you're using 100% outside air equipment, in this example, if it's 0 degrees outside and the design temperature is 70 degrees inside, heating that outside air up from 0 to 70 degrees only provides BTUs that are usable to cover your air load. And only once you raise that discharge temperature up above your space temperature do you get BTUs that are usable to cover the conduction load of the space. We call this usable or net BTUs. So take, for example, a blow-through style unit that we allow to discharge at 160 degrees. In this example, you're going to get 1,118 usable BTUs for every 10,000 CFM of air that you provide to the space. So to cover the conduction load in this example would require 10,000 CFM. But if we restrict the discharge temperature to 120 degrees, like you typically see with draw-through equipment, you can see they only get 492 MBH of usable BTUs for every 10,000 CFM. Because the discharge temperature is a lot closer to the space temperature, you're getting less usable BTUs. And you can see now it requires 24,000 CFM to be able to cover the conduction load of the space. I think we can all see the issue with providing 2.5 times the airflow. You're going to have equipment that's much larger, more costly, and difficult to install. And you're also going to be wasting energy, both in fan horsepower from providing 2.5 times the airflow, but also in fuel usage, as you're providing much more outside air than would otherwise be required for the space, well above what the natural infiltration would be, well above what the ventilation requirements for the space would be. Whereas that blow-through style unit is much closer to just offsetting the natural infiltration, which optimizes the energy usage for the space. Another question we get often is HTHV with 160-degree discharge. Are you worried about stratification? Well, we avoid that with our very high velocity discharge coming out of the unit at a 45-degree angle, anywhere from 1,500 to 2,200 feet per minute, sweeping that air down across the floor and back and sweeping and inducing any stratified ceiling heat, getting extremely even temperatures throughout the facility. The high discharge temperature also gives us a very high induction ratio, a 10-to-1 induction ratio, meaning for every CFM of air that our supply fan provides, we're moving 10 CFM of air around in the space that was already there. Because we're positively pressurizing the space as well, we're reducing the infiltration around the exterior, which makes for much more comfortable perimeters of the space. Also a huge value for the money. So with a single S-series heater, you can displace 6 high-efficiency unit heaters. You no longer require an HVLS fan for air distribution and air movement and destratification. You also no longer require a heated dedicated outdoor air system to provide ventilation to the space. So as opposed to having 3 sets of equipment that all require installation, an integrated control strategy, service, and maintenance. You can replace that with a single HTHV unit that provides the heat the space needs in a single package, the ventilation the space needs in a single package, and the destratification that the space needs in a single package. Along with that, it's going to provide superior energy efficiency, and it's also going to last for an extremely long time, 25 to 30 years. Now, if you reach out to Cambridge Air Solutions, we'll run a heat load for your space. We'll help you lay out the equipment. But just so you understand how we typically think about applying these, we're looking more at Zone 1 and Zone 3 designs, mounting the unit near the loading dock doors, blowing it into either large open spaces or through the aisles of the racking, as opposed to Zone 2, blowing it into the side of the racking is not preferred because it's going to disrupt your airflow. But if you look at Zone 1 or Zone 3, that's what's going to give you your optimum air distribution. Extremely flexible designs, just as we have with our M-Series units, through wall and rooftop units being most common, but your other options being available as well for facilities where you need to make some additional considerations. So we're running low on time. I'll just jump straight into really any questions. Reach out to your Long Building Technology sales engineer, and I'll pass it off to Austin to give out this week's prizes.
Awesome. Great job, Jacob. Appreciate you jumping on this week's coffee break and diving through the Cambridge Air Solutions product line. This week's prizes, gift cards, Legos, popcorn machine. Join us next week for high performance energy recovery glycol loops with Nick Bryant. Thanks for joining, and hopefully we'll see you at opening day tailgate next Friday. Thank you.